Hey everyone, how's it going? So today I wanted to make a quick video explaining how we can use the distance formula to find the distance between a couple of points. So if you haven't seen my last video, in the last one I explained what the distance formula is and how it can be derived using the Pythagorean theorem. So if you're at all confused with the distance formula, I highly recommend that you check that video out. There's some really great information in there that'll help you along the way. So let's go ahead and get into example number 1. So as you can see, in example number 1, we're asked to find the distance between P1 and P2. We're already given our coordinate points, our x's and our y's, so all we have to do is simply plug those values into our formula. So as you can see here, what I've done is I've replaced the x and the y's of the formula with the values that we have for our P1 and our P2. So what we have to do from here is simply do some simple calculations and calculate what the distance is. So for the first part, we have 3 minus negative 4, which would give us a positive 7 squared. For the next one, we'd have a negative 3 squared. Remember, that's all square rooted. Okay, and from here on out, we're just going to continue this, and what we are going to get is simply 49 plus 9. Remember, a negative squared is simply saying negative 3 times negative 3, which would give you a positive. So from here, we simply have the square root of 58, or if you want to get that to decimal form, that would simply be 7.62. Now, there's no right or wrong answer there. Either one of those is both acceptable. It just really depends on what the problem is asking you for. Okay, so that was a pretty simple example. All we had to do was, take those 2 points that were given to us, plug in those x's and those y's into the formula, and simply calculate that out. So let's look at example number 2. Example number 2 is a little bit more in depth. We have 3 points to start off with. We have to find the length of each side of this triangle, and we have to determine whether this triangle is a right triangle or not. So let's go ahead and look at part A. So part A wants us to find the length or the distance of each side of this triangle. So what we can do is set this up by basically saying the distance between A and B, the distance between B and C, and then the distance between A and C. Okay, so looking at side AB, meaning this side here, we have our points, and we're going to call this one x1, this one y1, x2, and y2. So now we can simply plug those values into our distance formula, which basically states x2, which is 2 in this case, x1, which is negative 2 in this case, plus y2, which is 3 in this case, minus y1, which is 1 in this case, squared, all under square root. So calculating that out would simply give us 16 plus 4. And then simplifying that out would give us a square root of 20. And if you'd like to simplify that even further, you could separate that 20 and say that that's 4 times 5. And then we can take the square root of 4, which would give us 2 square root of 5. Okay, now let's look at side BC. So for BC, we'll take into consideration that B is our x1, y1, x2, and y2. Now, there really isn't any difference. You could really name them whatever you want, but I'm just trying to keep the same convention that we're going with here. So that's how we'll do it from here. So again, we're just going to use those values and plug them into the distance formula, which will basically be 3 minus 2 squared plus 1 minus 3 squared. simplifying that out would basically give us 1 plus 5. I'm sorry, 1 plus 4. Let me go ahead and erase that. And then that would simply be square root of 5. And you could leave that as a square root. You could also simplify it out into decimal, but for this case, we're just going to leave it as is. Okay, now let's look at this last side, which is side AC. And again, we're going to name this our x1, y1. This will be our x2, y2. Now plugging that in would basically give us 3 minus -2 squared plus 1 minus 1 squared. So as you can see here, the 1 minus 1 is going to turn into a 0. 0 squared is 0. So we can basically knock this out right from the get-go. And all we have left is 3 minus -2, which would be a positive 5. And squaring that would give us 25. Then, of course, square rooting that would simply give us 5. Alright, so for part B of this example, we're asked to determine whether this triangle is a right triangle or not. So there's a couple of things we'll have to take into consideration, and that is, one, we'll have to use Pythagorean theorem, and we'll assume that the 90-degree angle of this right triangle is going to be at the vertex of B, right? So with that in mind, we can begin to solve or verify whether this triangle is a right triangle. All right, so let's go ahead and write out the Pythagorean theorem. So the Pythagorean theorem, we'll call it PT for short, simply states that c squared is equal to a squared plus b squared. And these would basically be the sides of our triangle. So if we let, based on the picture, if we let, say, side AC down here be our hypotenuse, right? And plug in that value that we calculated, which we calculated to be a 5. Let's go ahead and plug that into the formula. We'd have 5 for our side C. We're going to square that. We'll have, let's call side AB our A value, and we'll call BC our B value. So let's go ahead and plug what we calculated. So that would basically be 2 square root of 5 squared plus square root of 5 squared. So now what we've gone and done is basically taken our values, plugged them into the Pythagorean theorem, and if we are able to get both sides to be the same value, that basically gives us our check, and it lets us know that this triangle indeed is a right triangle. So what that means is basically take the 5 squared, for example. That's going to be 25. Now if we solve out the other side, this square here is going to square both of these values inside, right? So that would give us a 4 multiplied by a 5, because the square is simply going to knock out that square root on that 5. Same thing here. All it does is knock out that square root. We're left with 5. And then simplifying that even further, we still have the 25 on the other side. Multiplying this 4 and 5 is going to give us a 20 plus 5. And what we can begin to see is that both sides are equal to each other, which means yes, this triangle checks out, and it indeed is a right triangle. Alright guys, so that brings us to the end of this video. We've gone ahead and solved both of these examples. I hope that this was able to explain a few things if you had any confusions with anything. And again, if you haven't checked out my first video, definitely do that. There's some great information in there. And please rate, like and comment this video if you liked it. If you didn't like it, it really helps me in making these videos moving forward. Thanks again. Catch you on the next one.